Some of the world's most ambitious engineering projects have also been the most financially disastrous. These real-life projects went massively over budget, so here are the top 15 most over-budget mega projects. Starting with number 15, the Berlin-Brandenburg Airport. Berlin-Brandenburg Airport, originally conceived to be a symbol of German efficiency and a key transport hub in Europe, instead became one of the most infamous examples of a project plagued by massive delays and cost overruns. It's located just outside the German capital, and it was first proposed in the early 1990s after the reunification of Germany. The idea was to consolidate Berlin's multiple outdated airports into one state-of-the-art facility. The initial cost estimate was around 2 billion euros, with a planned opening in 2011. Instead, the project ballooned to over 7 billion euros, and the airport didn't open until October of 2020, 9 years later. The problems that led to this overspending were numerous and compounded over time. The airport's management was overly complex, with various contractors, planners, and engineers operating under poor oversight. One of the most costly mistakes was a disastrously designed fire protection system. The automated fire safety system was supposed to expel smoke efficiently from the terminals, but the engineering was so flawed that it never functioned properly. As a result, the entire system had to be torn out and redesigned, costing hundreds of millions of euros. Additionally, it was subjected to continuous changes in design midway through construction. Political decisions added unnecessary features and alterations, including luxury retail expansions and infrastructure that was not part of the original plans. These changes led to confusion among the contractors, and it necessitated structural revisions that required recertification. Adding to this debacle, the complete lack of realistic scheduling and risk planning, several high-ranking project managers resigned or were removed over the years, each time setting back progress. Thousands of defects ranging from non-working doors and escalators to cables laid incorrectly meant constant rework. The facility sat empty for years after its initial completion, with maintenance costs adding millions to the overall price. Public trust eroded as the delays and budget overruns became a national embarrassment. The situation became so notorious in Germany that BER became shorthand for bureaucratic dysfunction. When the airport finally did open in late 2020, it was already outdated in design compared to more modern European airports. And while now the airport functions, its legacy is a cautionary tale of what happens when poor planning, lack of accountability, and technical mismanagement collide in a high-stakes infrastructure project. Number 14. Boston's Big Dig. I knew the Big Dig was going to be in here somewhere. The Central Artery Tunnel Project, better known as the Big Dig, was one of the most expensive and controversial projects in U.S. history. It's located in Boston, Massachusetts. The project aimed to alleviate traffic congestion in the heart of the city by replacing the elevated Interstate 93 highway with a 3.5-mile underground tunnel. The original estimated cost of the Big Dig was around $2.8 billion when proposed in the 1980s. By the time it was completed in 2007, the total cost had surged to nearly $15 billion, with interest payments pushing the final tally closer to $24 billion. Numerous factors contributed to these cost overruns. From the outset, the Big Dig was an extremely ambitious undertaking in an urban environment with complex geologic and logistical challenges. Tunneling through a densely populated historic city required extensive rerouting of utilities, reinforcement of the aging buildings, and innovative engineering solutions that never had been tested at such a scale. The cost of acquiring the land, often through eminent domain, also exceeded projections. One of the major engineering difficulties involved groundwater management. As workers dug beneath the city, they encountered unstable soil and water intrusion, requiring elaborate waterproofing systems. In 2004, a ceiling panel in one of the tunnels collapsed and killed a motorist, triggering widespread scrutiny of the project's safety standards. The collapse was traced back to the use of poor construction materials and insufficient anchoring, another symptom of oversight failures. The project was riddled with political interference and corruption. Mismanagement, fraudulent billing by contractors, and lack of centralized control led to expensive delays. The sheer number of subcontractors working on different segments of the project made it difficult to even enforce a uniform standard. Multiple audits revealed that cost estimates were deliberately kept low to secure initial political approval, only for true cost to become apparent once the work was underway. Despite the massive costs, though, the Big Dig did succeed in transforming Boston's traffic flow. It did remove an elevated eyesore from the downtown skyline, it reconnected neighborhoods, and it reduced congestion in the city's core. Kinda. However, the project's legacy is still debated. Some hail it as a marvel of modern urban planning, others view it as an example of engineering overreach and fiscal irresponsibility. Its cost and myriad of technical and administrative problems remains a sobering case study in how even well-intentioned megaprojects can just spiral far beyond their original budgets. Number 13. The Sydney Opera House. Hey, we just talked about this one in a previous episode. The Sydney Opera House. It's one of the most iconic landmarks in the world, and it's recognized for those soaring white shells and stunning harborfront location. But its construction story is one of the most dramatic examples of an engineering project gone wildly over budget and over time. When first proposed in the late 1950s, the estimated cost for the Opera House was $7 million Australian dollars, with a planned completion in 4 years. Instead, the building took 14 years to complete and ended up costing about $102 million Australian dollars, more than 14 times the original estimate. The root cause of the budget disaster began with the design itself. Danish architect Jørn Utzon won an international design competition in 1957, but his concept, a series of sail-like roof structures, was unlike anything that had ever been attempted. There was no precedent here, no engineering model, and no blueprint for how to physically construct the curved forms of the roof. Construction began before structural engineering was complete, leading to constant changes and modifications. The project had to be halted multiple times as engineers worked out how to make the roof not just visually appealing, but structurally sound. Eventually, a workable solution was found by cutting the roof shapes from sections of a sphere, which simplified fabrication and allowed for modular construction. However, that innovation came at a financial and time cost. And political interference further complicated the matters. The New South Wales government wanted to push ahead with the project for political reasons and began construction prematurely. As the project's challenges mounted, the public support wavered and Utzon became a scapegoat for delays and rising expenses. He resigned from the project in 1966 under pressure and never returned to see its completion. The final phase of construction was taken over by Australian architects who modified aspects of his original interior design. While the building is now regarded as a masterpiece and a UNESCO World Heritage Site, the legacy includes painful lessons about the cost of innovation without adequate planning. Ironically, had Utzon's original vision been fully implemented, including acoustics and seating arrangements, the building may have functioned better as a performance space. Even today, critics point out that its concert hall is not acoustically optimal. Well, despite its troubled beginnings, the Opera House ultimately became a symbol of national pride and a global cultural icon. Yet the sheer scale of that cost overrun remains a defining case in architectural history. Number 12. Montreal Olympic Stadium. The 1976 Summer Olympics held in Montreal and remembered not just for the athletic achievements, but for one of the most financially disastrous construction projects in Olympic history. The Olympic Stadium, often referred to as the Big O, or less kindly, the Big OOWE. Well, originally projected to cost around 120 million Canadian dollars, the final cost ballooned to over 1.6 billion Canadian dollars, with the city only managing to pay off the associated debt 3 decades later in 2006. The stadium was meant to be a modern marvel, featuring a retractable roof suspended from a 175-meter incline tower, the tallest of its kind in the world. However, almost everything that could go wrong did. Construction delays plagued the project from the outset. Labor strikes, cost inflation, political disputes, and a lack of coordination between the contractors and city officials drove the costs even higher with every passing year. The retractable roof, intended as the stadium's showpiece, was never operational during the actual Olympics. In fact, the tower itself wasn't even completed in time. The stadium was unfinished, and temporary structures were used to accommodate the games. The retractable roof, when finally installed more than a decade later, was plagued by failures. It tore multiple times during weather events and eventually had to be replaced by a fixed roof. To fund the project, the Quebec government imposed a special tobacco tax in 1976, which continued for 30 years until the debt was repaid. Montrealers bore the financial weight of the stadium for a generation, and the debacle led to a long-term skepticism about hosting large international events in Canada and effectively halted the Olympic bids from the country for decades. Critics argued that much of the cost could have been avoided with better planning, maybe realistic budgeting and more transparent management, and the provincial government took control of the project midway through construction, a move that reflected just how far off track the original organizers had veered. Today, the stadium still stands and is used for various sporting events and entertainment, but it struggled to find a consistent purpose. Renovation and maintenance costs continue to mount, and the structure remains one of Canada's most controversial public works projects. Number 11. The Suez Canal expansion in Egypt. In 2015, Egypt completed what was widely promoted as a transformative expansion of the Suez Canal, a project the government described as the new Suez Canal. Well, the initiative aimed to enhance Egypt's role in global trade by increasing the canal's capacity, reducing ship wait times, and generating massive revenue boosts for the Egyptian economy. Originally budgeted at $4 billion, the final cost swelled to more than $8.2 billion, with the project also raising concerns about its economic justification, its rushed execution, and its long-term return on investment. The idea behind the expansion was straightforward in principle, but it was complex in execution. The Suez Canal is one of the most vital shipping lanes in the world. It connects the Mediterranean Sea to the Red Sea and serves as the shortest maritime route between Europe and Asia. The goal of the expansion was to add a 35-kilometer-long parallel channel to allow two-way traffic in a key segment of the canal. Additionally, nearly 40 kilometers of the existing waterway were dredged and widened, and the total project spanned about 72 kilometers. The plan announced by President El-Sisi in 2014 was ambitious. While similar projects would typically take 3 to 5 years, the Egyptian government insisted the entire expansion could be completed in just 1 year. To fund the initiative, Egypt issued investment certificates to its citizens, raising more than $8 billion in a matter of days. While the campaign was successful in terms of fundraising, it placed enormous pressure on the timeline and the execution of the work. To meet the deadline, more than 40 dredging vessels from international companies were brought in, working around the clock. This was one of the largest dredging operations in human history. The rushed schedule came with consequences, though. Environmental studies, risk assessments, and economic forecasts were either accelerated or omitted together. Critics argued that the haste was driven more by political symbolism than economic necessity. The project became a centerpiece of national pride, heavily publicized, with a massive inauguration ceremony broadcast globally. But beneath the surface, several red flags were emerging. Shortly after the project's completion, analysts began to question the canal's actual performance improvements. The government had projected that annual revenue from the canal would nearly triple, from $5 billion to $13.5 billion within 8 years. In reality, global maritime trade didn't expand at that anticipated rate, and the growth in the canal usage lagged. A slowdown in world shipping volumes and changes in oil prices led to fewer ships taking the route. The actual revenue increase has been modest, and in some years canal earnings even declined. But beyond the economics, there were operational risks that went unaddressed. The expansion didn't include major improvements to any traffic management, navigation systems, or even support infrastructure. These shortcomings came into focus in 2021 when the container ship Ever Given ran aground in the canal and blocked traffic for 6 days. Though the blockage occurred outside the newly expanded section, it showed the fragility of canal operations and the limits of the expansion in addressing real-world bottlenecks. By prioritizing speed and symbolic achievement over long-term planning, the Egyptian government may have undermined the very goals it sought to achieve. Many international financial institutions expressed concern that the canal's expansion was not backed by a rigorous cost-benefit analysis. Critics inside and outside Egypt pointed out that the $8.2 billion could have been better spent on other projects like ports, logistics hubs, or transportation systems. In the years since its completion, the expansion has remained a source of debate. On one hand, it reinforced Egypt's position on the global shipping map and demonstrated the country's engineering capabilities. On the other, it became a cautionary tale about political ambition overtaking economic reality. And while the canal remains operational and globally significant, the expansion's ballooning budget and the questionable return on investment show how even strategically important infrastructure like this can falter without balanced planning and realistic expectations. Number 10. The Scottish Parliament Building. The construction of the Scottish Parliament Building in Edinburgh is a classic example of how civic ambition and political dynamics can combine into a project that spirals dramatically out of financial control. Initially budgeted at between 10 to 40 million pounds when first proposed in the 1990s, the final cost of the building reached about 414 million pounds. By the time it officially opened in 2004, it was over 10 times the upper estimate. The construction remains one of the most controversial episodes in Scottish political history, and it is still discussed in the UK as a cautionary tale in public project management. The idea for the Scottish Parliament emerged after the 1997 devolution referendum, in which Scotland voted to re-establish its own legislature after nearly 3 centuries of political union with England. As part of the process, the UK government promised a new purpose-built home for the Scottish Parliament in the capital, Edinburgh. The original cost estimates were modest, with initial expectations of adapting existing infrastructure or erecting a basic modern building, but those expectations changed dramatically with the choice of location, design, and scope. The design competition was won by a Spanish architect, Enric Morales, whose concept was inspired by Scottish landscapes, boats, and plants. The resulting design featured complex curved forms, asymmetrical structures, and the use of materials that are diverse, including granite, steel, oak, and glass. And while undeniably unique and visually striking, the design was notoriously difficult to execute. It required specialized construction techniques, custom fabricated components, and precise craftsmanship, features that were not accounted for in the original budget. The decision to build the structure at the base of Edinburgh's historic Royal Mile further complicated the project. The site was geologically and historically sensitive. It required extensive groundwork, archaeological surveys, and adjustments that slowed progress and drove up costs. Enric Morales' untimely death in 2000 added to the difficulties. With the original architect no longer able to guide the project, disputes rose over how to interpret and complete his vision. Contractors struggled to reconcile architectural flourishes with the construction realities. As the complexity grew, so did the labor and the material cost. At one point, over 1,000 workers were on site to meet deadlines, significantly increasing overhead. The project was also plagued by shifting political priorities too, and a lack of clear accountability. An official inquiry known as the Fraser Inquiry was launched to determine what went wrong. The findings were damning. The inquiry cited poor cost control, ineffective project governance, and excessive alterations as primary reasons for the ballooning cost. It found that the government failed to maintain a realistic budget and that initial cost estimates were overly optimistic and politically motivated. Despite all the overwhelming financial overrun, though, the completed building received numerous architectural accolades. It won the 2005 Sterling Prize, and it's been praised for its symbolism. Yet many Scots remain angry that such a massive sum of taxpayer money was spent on a structure intended to represent transparency, democracy, and fiscal prudence. Now, today, the Scottish Parliament Building functions as the legislative heart of Scotland. It is open to the public and it features exhibition areas, public galleries, and committee rooms, in addition to the main debating chamber. While the controversy over its cost has gradually faded, it has left a permanent mark on public discourse in the UK. Number 9. The Channel Tunnel between the United Kingdom and France. The Channel Tunnel, it's often called the Chunnel, is a 50.5-kilometer rail tunnel connecting the UK to France beneath the English Channel. Opened in 1994, after more than 6 years of construction, it was hailed as one of the greatest civil engineering feats of the 20th century. However, the final cost of the project soared far beyond the original budget, making it one of the most infamous examples of infrastructure overspending in modern European history. When construction was approved in 1986, the tunnel's estimated cost was £4.7 billion. By the time it was completed, the actual cost had reached more than £9 billion. That's over $21 billion in today's dollars, doubling the original estimate and causing serious financial strain for investors and governments. While the tunnel has ultimately proven to be a vital link between the UK and mainland Europe, its journey from blueprint to reality was marred by design changes, financial struggles, unforeseen engineering, and regulatory complexities. One of the major reasons for the budget overrun was the ambitious nature of the engineering. Boring a tunnel under a body of water like the English Channel involved considerable risk. The geologic makeup of the seabed had been surveyed before, but only to a limited extent. As construction proceeded, crews encountered unexpected conditions, including unstable chalk formations and pockets of pressurized water. These challenges slowed the tunneling operations and required reinforcement systems. The project involved 3 parallel tunnels, 2 for trains and 1 central service tunnel, each with a sophisticated ventilation, fire protection, and emergency escape mechanism. At its peak, more than 13,000 workers were employed on both sides of the channel, with over 8 million cubic meters of soil excavated. The scale and complexity of coordinating equipment, safety protocols, and engineering techniques across 2 different countries, each with different construction standards and regulatory frameworks, proved way more difficult than expected. Now, despite the problems, the Channel Tunnel eventually stabilized and it grew into a critical infrastructure link. It is now widely used for both freight and passenger transport, cutting travel time between London and Paris to just over 2 hours. The legacy of the tunnel is complex. On one hand, it is a marvel that overcame unprecedented challenges to physically connect 2 major economies. On the other, it serves as a reminder of what can go wrong when ambitious infrastructure projects underestimate costs, overestimate demand, and proceed without clear mechanisms for financial control. Number 8. The Sochi Winter Olympics in 2014. The 2014 Winter Olympics, held in the Russian resort city of Sochi, are remembered not only for their feats of athleticism and lavish ceremonies, but also for becoming the most expensive Olympic Games in history. Originally budgeted at about $12 billion, the final cost exceeded $50 billion, a staggering figure that drew global criticism and allegations of mismanagement, corruption, and political grandstanding. Sochi wasn't a traditional choice for the Winter Olympics. Before its selection in 2007, the city was known more for its subtropical climate and beaches than snow sports. Building a world-class winter sports infrastructure in a region that lacked even basic winter facilities required constructing everything from scratch: ski resorts, high-speed railways, highways, tunnels, hotels, Olympic stadiums, and even artificial snow production systems. This transformed Sochi into a construction zone of unprecedented scale. At the heart of the expanse was the development of the Olympic Park in Adler, the mountain cluster in Krasnoye Polanya. Entire new towns were built for athletes, journalists, and visitors. Roads were widened, new airports were developed, and high-voltage electric lines and water supply systems were laid deep into the mountainous terrain. One of the single most expensive segments was the 48-kilometer combined highway and railway from Adler to Krasnaya Polyana, which alone cost more than $9 billion, more than the entire cost of some previous Winter Games. A 2013 report by opposition politician Boris Nemtsov alleged that up to $30 billion had been lost to graft and inflated contracts. State-controlled corporations received the lion's share of the construction deals, often with minimal competition or even basic transparency. Contractors reported being paid late, overbilled, or required to revise completed sections due to shifting political demands. Many vendors went bankrupt before the opening ceremony. Beyond the corruption, though, the rush to meet deadlines caused enormous strain. Construction was round the clock for years, and workers were brought in from across the former Soviet Union, often housed in substandard conditions, and labor abuses were reported by international watchdogs, further tarnishing the event's image. After the Games concluded, many of the new-built facilities fell into disuse or disrepair, a classic case of white elephant problem that plagues many Olympic host cities. The ski venues that required constant artificial snow became economically unsustainable. Some hotels were abandoned, the Olympic Village was converted into luxury housing that struggled to attract any buyers, and critics argued that the long-term economic benefit to the region was negligible relative to the investment. From a geopolitical perspective, though, Sochi was used by Vladimir Putin's government to showcase Russia's resurgence on the world stage. The timing of the Games, just weeks before Russia's annexation of Crimea, lent the event a surreal atmosphere, one of global celebration that quickly gave way to international tension. Despite all the extravagant spending, though, Sochi 2014 was praised for its technical execution. Events were held on time and with few logistical hiccups. Security was tight but effective. The venues themselves were modern and impressive. But the question of value remains central. Was the price tag worth it for Russia? Moving on to number 7, the California High-Speed Rail. Oh boy, the California High-Speed Rail project was once envisioned as a revolutionary leap forward in the American infrastructure, a state-of-the-art bullet train connecting major cities across California, modeled after successful systems in Japan and Europe. The plan was ambitious, to say the least, 800 miles of high-speed rail lines linking San Francisco to Los Angeles, with eventual extensions onto Sacramento and San Diego. Trains will travel at speeds of up to 220 miles an hour, drastically reducing the travel time while also cutting carbon emissions. When California voters approved the project in 2008 via Proposition 1A, they were told the initial segment from San Francisco to Los Angeles would cost around $33 billion and be completed by 2020. As of 2025, the project remains unfinished, over budget, and politically mired, to say the least. The estimated cost has since ballooned to over $128 billion, nearly 4 times the original number. Several key issues have led to the dramatic budget overruns. First and foremost, land acquisition. Routing the tracks through California's densely populated and highly regulated urban centers required the purchase of hundreds of properties, often through lengthy legal battles with landowners. Delays and lawsuits over eminent domain, environmental impact assessments, and right-of-way disputes cost the project years and billions. Compounding the issue is a constantly shifting political environment. Changes in state leadership, federal funding, and local opposition have all altered the project's scope repeatedly. Former President Obama supported the initiative and awarded billions in federal grants, but the Trump administration rescinded some of those funds, leading to more financial instability. Governor Gavin Newsom, while supportive in principle, has scaled back the ambitions, refocusing efforts on completing a 171-mile stretch between Merced and Bakersfield in the Central Valley. This interim segment, as he calls it, though crucial for testing and proof of concept, is far from what was originally promised. A 2018 audit by the California State Auditor found that the High-Speed Rail Authority had consistently failed to manage risks, relied on outdated cost estimates, and lacked proper oversight over contractors. Coordination between agencies, consultants, and the local government has been poor, to say the least, with confusion over who's responsible for specific parts of the construction pipeline. Critics argue that billions are being poured into a route few people will even use regularly, raising concerns about ridership revenue, long-term financial sustainability, and whether the rest of the system will ever be built. Despite the challenges, the project's not entirely been without progress. As of 2025, more than 119 miles of track bed are under construction, with dozens of bridges, overpasses, and viaducts either completed or nearing completion. The state continues to secure funding, including partnership with local governments and private contractors, and some believe the scaled-down segment could eventually expand again, if political and financial conditions improve. Number 6. Denver International Airport. When Denver International Airport opened in February of 1995, it was the largest airport in the U.S. by land area, and one of the most technologically advanced, too. Spanning over 33,000 acres, nearly twice the size of Manhattan, it was designed to be a world-class hub that would position Denver as a major player in global aviation. But the road to completion was anything but smooth. Originally budgeted at $1.7 billion, with an opening date set for October 1993, the airport ultimately opened 16 months late and at a final cost of $4.8 billion, nearly triple the original estimate. Now, the central cause of the budget explosion was the attempt to deploy new technology, particularly this fully automated baggage handling system. Designed by BAE, this system was meant to revolutionize luggage transportation, sorting, scanning, and delivering baggage at high speeds with any minimal human intervention. The concept was bold, but the reality was disastrous. The system went through continual breakdowns, misrouting bags, damaging luggage, and requiring human intervention to even function. And despite the repeated attempts to fix it, the system never worked as intended. Engineers brought in to troubleshoot the issues recommended a complete redesign, but at that point, the system was already deeply embedded into the airport's architecture. After spending an estimated $560 million on the failed systems, the Denver International Airport eventually scrapped most of it, reverting to traditional manual baggage handling. This debacle became a case study in technology overreach and underestimating integration. In addition to the baggage systems, delays were caused by poor project coordination between city officials, architects, and contractors. Political infighting among Denver's city leaders and changes in project leadership added more layers of confusion and halted progress at multiple points. Several firms walked off the job over payment disputes or unclear specifications, which forced renegotiations that added both time and expense. The design complexity didn't help either. The airport's now iconic peaked roof, meant to resemble the Rocky Mountains and constructed from Teflon-coated fiberglass, was more difficult and expensive to install than projected. While visually striking, it added significant challenges and maintenance demands that hadn't been fully accounted for in the early budget. When it finally opened, it was under a cloud of skepticism and ridicule. Media outlets published exposés about the cost overruns, and the failed baggage system became a national punchline. Today, though, the airport is one of the busiest and most efficient airports in the U.S., serving over 69 million people annually as of early 2020s and acting as a hub for multiple airlines. The whole project underlines the importance of realistic budgeting, stakeholder coordination, and risk management in any large-scale engineering endeavor. Number 5. The Berlin Hauptbahnhof. Berlin Hauptbahnhof, or Berlin Central Station, is now one of the busiest and most modern rail hubs in Europe. It's located in the heart of Germany's capital, and it serves as a symbol of Berlin's post-reunification ambition to become a center of European connectivity. But while it's widely praised for its architecture and beauty and functionality, its construction was plagued by delays, planning flaws, and cost overruns. Initially projected to cost around 700 million euros and opened in time for the year 2000, the final price tag reached nearly 1.2 billion euros, and the station opened 6 years late in 2006, just days before the start of the FIFA World Cup. The idea for a central station in Berlin came after German reunification in the 1990s. While there was a clear need to modernize and unify the fragmented rail infrastructure that had been split during the Cold War, the design by architect Maynard von Gerken featured a complex multi-level structure with east-west and north-south lines crossing beneath a huge glass and steel roof. The station would replace several older terminals and become the focal point for a newly integrated rail system across Germany. One major contributor here to the station's budget overruns was the site itself. The area around the Lercher Bahnhof was historically significant and geologically challenging. As the station design evolved, the foundations had to be modified repeatedly to accommodate existing utilities, unexpected ground conditions, and archaeological findings. Water management, too, became a major issue due to Berlin's high groundwater. Design changes played a huge role in pushing the costs higher. The ambitious vision included a 321-meter-long glass roof suspended high above the main concourse. The size and curvature of this structure presented huge challenges during construction. Significant flaws emerged too. In 2005, during a windstorm, part of the roof collapsed. While no one was injured, the incident led to a complete reassessment of the structural integrity of the roof. Another major issue was political interference. Deutsche Bahn, the German railway operator, was under pressure to deliver the station in time for the World Cup in 2006, which meant accelerating construction schedules and cutting corners in quality and safety. This culminated in a now infamous decision to shorten the station's roof by more than 100 meters without consulting the original architect, leading to a highly publicized legal dispute. The architect von Gerken later won lawsuits against Deutsche Bahn, arguing that his design had been violated and his intellectual property compromised. Number 4. Wembley Stadium. The new Wembley Stadium in London, home to England's national football team and one of the most iconic sports venues in the world, is another high-profile example of a project that went massively over budget. The original stadium opened in 1923 and, famous for its twin towers, was demolished in 2003 to make way for a modern 90,000-seat arena with a striking design. When the project was first proposed, the estimated cost was around £400 million. By the time it opened in 2007, the total had soared to £798 million, nearly doubling the initial figure, and that doesn't even include the additional infrastructure, legal, and financing costs. At the heart of the stadium's financial troubles was a combination of design complexity, contractual dispute, and political pressure, of course. Designed by Foster & Partners and HOK Sport, with engineering by Mott MacDonald and structural input from the renowned Buro Happold, Wembley was intended to set a global benchmark. Its signature feature, a 133-meter-high steel arch spanning over the stadium and supporting the entire roof, was both innovative and unprecedented. However, translating this bold concept into reality proved exceptionally difficult. Construction was managed by Multiplex, that's an Australian company, making its first foray into the UK market. The company quickly became embroiled in disputes with subcontractors, particularly the firm responsible for the roof steelwork, Cleveland Bridge. The relationship deteriorated to the point where Cleveland Bridge was removed from the project in 2004 and then replaced by Dutch firm Hollandia. This fallout led to lawsuits that dragged on for years and cost tens of millions in legal fees alone. Delays were also caused by complications in constructing the foundations. The old Wembley's underground infrastructure proved more difficult to remove than anticipated, and when excavation began, builders discovered hidden structures, unaccounted for services, and contaminated ground. This just added months of delay before any above-ground work could even begin. The roof, engineered to be partly retractable and supported entirely by the massive arch, faced some repeated technical problems. Sections of the arch had to be refabricated due to misalignments, and the design had to be recalculated mid-project after structural integrity concerns emerged. Each adjustment required new approvals, more testing, and more money. The financial structure of the project also added some complications. Now, initially, the UK government and the Football Association clashed over how much public funding should be used. Eventually, the National Lottery and other public sources provided hundreds of millions in funding, but the financing model remained fragile. Multiplex repeatedly warned shareholders of losses, and the delays impacted not only the contractor, but the FA's event schedule and their national football planning. Legal disputes, of course, escalated between Multiplex and the FA, as well as between Multiplex and subcontractors, and at one point the entire project appeared to be at risk of collapse due to accusations of mismanagement, cost inflation, and missed deadlines. Internal emails and documents later revealed that Multiplex had severely underestimated the complexity of the build, and that communication between parties had broken down entirely by 2005. When Wembley finally opened in March of 2007, after nearly 4 years of delay, it was met with both admiration and frustration. The finished stadium was architecturally stunning, and it had world-class facilities, but the long shadow of its construction troubles still lingered. Critics questioned whether the stadium's costs were justified, and some called for greater transparency in how public money had been used. Today, though, Wembley Stadium is fully operational and continues to host major football matches, concerts, and international events. It is considered a success in terms of usage and popularity. But behind the spectacle is a troubled financial history marked by missed deadlines, poor contractor relationships, and a total cost that spiraled far beyond what was sold to the public. Number 3. The Moes Flood Barrier Project in Venice. The Moes project, short for Modulo Sperimentale Elettromeccanico, was designed to save the city of Venice from one of its greatest threats, flooding. Intended to shield the Venetian lagoon from high tides and storm surges, this ambitious engineering effort began in 2003 with an expected budget of €1.6 billion and projected completion date of 2011. Instead, the project took nearly 2 decades to become operational, and it ultimately cost over €7 billion, more than 4 times the original estimate. Venice has long been considered one of the most beautiful cities in the world. It's also been one of the most endangered. It's built on wooden piles driven into a marshy lagoon. The city's been slowly sinking for centuries, and rising sea levels and increasingly severe weather patterns have only made matters worse. Acqua alta, or high water, has become a regular phenomenon now, flooding St. Mark's Square and damaging priceless architecture and their cultural heritage. To address all this, the Moes system was conceived. 78 mobile gates installed at 3 inlets where the lagoon meets the Adriatic Sea. These gates are designed to rise during high tides, blocking seawater from entering the lagoon and preventing catastrophic flooding. It's a complex system, with underwater foundations, hydraulic pistons, and movable steel barriers anchored to the seabed, requiring careful, continuous maintenance. From the start, it was challenged by technical complexity, but the main reason for the project's massive cost overruns and delays were poor project management, changing requirements, and a widespread corruption. The project's management was handled by a private consortium given extraordinary control and little oversight. This lack of transparency opened the door to financial mismanagement on a massive scale. In 2014, a sweeping investigation by Italian prosecutors exposed a massive bribery scheme involving dozens of high-level officials, contractors, and politicians. It was discovered that more than 1 billion euros had been misappropriated through inflated invoices, kickbacks, and false contracts. Giorgio Orsoni, then mayor of Venice, was arrested along with other public figures. These revelations brought the construction to a near halt, and it led to a complete restructuring of the project. For many Venetians, this scandal came to symbolize the corrosive impact of unchecked bureaucracy and collusion between government and private industry. Meanwhile, the engineering challenges persisted. The seabed foundations had to be reinforced multiple times due to shifting sediment, corrosion problems in the steel gates, improper materials used in construction, and water infiltration all contributed to the added rework and delays. But by 2020, after repeated delays and public frustration, Moe's gates were used for the first time during an exceptionally high tide, and they worked. In October of that year, the gates successfully prevented St. Mark's Basilica and the surrounding areas from flooding. It was a symbolic victory after years of criticism and disappointment. However, regular use was still not possible until full systems testing and refinement continued into 2021 and beyond. As of 2025 right now, Moe's is considered partially operational, with plans to eventually automate its flood response system fully. Maintenance, long-term operation costs, they're expected to be high, with annual upkeep projected at over 100 million euros. Environmentalists have also raised concerns that frequent closure of the lagoon may disrupt the natural water flows, damaging the fragile ecosystem of the Venetian lagoon in the long term. Number 2. Kansai International Airport, Osaka, Japan. Kansai International Airport, or KIX, it's one of the most remarkable airports ever constructed, a marvel located directly on an artificial island in Osaka Bay. Opened in 1994, it was Japan's response to the growing need for a modern gateway to relieve congestion from Osaka's Itami Airport. While Kansai has been praised for its design and engineering, it's also a textbook case of cost overruns. The project was initially projected to cost about $8 billion, with the airport expected to be completed in a relatively straightforward manner on a 4-kilometer-long man-made island. By the time the first phase opened, the actual construction cost had more than doubled to over $20 billion, and Japan's taxpayers were left with one of the most expensive civil engineering projects in modern history. The final tally, including debt servicing and subsequent expansions, has been estimated to reach as high as $30 billion. Now, one of the primary drivers of this overrun was the island itself. Building in the middle of Osaka Bay meant contending with deep, soft seabed clay that continued to compress long after construction began. The island sank more than anticipated, initially predicted to subside by about 5 meters over 50 years. It's already sunk more than 8 meters within the first decade. Engineers had to keep raising the seawalls and jacking up structures like the terminal building and runway to keep the airport operational and safe. These corrections were expensive and difficult, involving massive hydraulic lifting systems and continuous monitoring. To protect the airport from earthquakes and typhoons, 2 frequent threats in the region, Kansai was built with deep-seated seismic foundations and storm-resistant breakwaters. Now, while these features have proven effective, they've added significant cost and complexity. Architecturally, though, the airport is a masterpiece. Renzo Piano's design for the main terminal, a single, graceful, curving structure over 1.7 kilometers long, is both aesthetically striking and highly efficient. However, the commitment to such a bold design also contributed to the budget overruns. Constructing this massive roof using advanced cantilevered trusses and prefabricated modules required precision engineering, and it was far more expensive than traditional airports. Kansai has faced difficulties attracting as many passengers as originally forecast too, particularly in its early years. It was hit hard by the Asian financial crisis of the late 90s and saw lower than expected demand. Debt repayment became a growing concern, and the airport's finances were further strained after the 2011 Tohoku earthquake and tsunami, which temporarily reduced air travel across Japan. In response, the Japanese government had to restructure the airport's debt and eventually privatize operations in 2016, leasing the management rights to a consortium led by Vinci Airports. Well, despite all the cost overruns and challenges, Kansai International Airport has since been evolving into a functional and celebrated airport. It's weathered typhoons and earthquakes successfully, and it's considered an important hub in the Asia-Pacific region. The terminal is admired still for its layout and passenger experience, and the airport's resiliency in the face of these environmental threats is widely respected. Number 1. The Montreal REM Express Metropolitan, the REM, Canada. The REM Express Metropolitan, the REM, is a major new automated light metro system being built in Montreal, Canada. Touted as one of the largest public transit expansions in North America, the REM was designed to span over 67 kilometers and include 26 stations, connecting downtown Montreal with its suburbs, the airport, and the South Shore. Initially announced in 2016 with a budget of $5.5 billion Canadian dollars, the project has since experienced some significant cost overruns, with estimates now suggesting $7.9 billion as of 2024, a nearly 45% increase. Planned and financed by CDPQ Infra, a subsidiary of Quebec's public pension fund manager, the REM is a public-private partnership intended to modernize transit in a city long underserved by reliable suburban rail. However, the complexity of the project quickly turned and outpaced initial estimates. One of the most challenging elements has been the integration of new automated systems into Montreal's existing infrastructure, especially the conversion of the Mount Royal Tunnel. That's a 5-kilometer-long historic tunnel built in 1918. Originally intended for commuter trains, the tunnel required extensive reinforcement, asbestos removal, and upgrades for new signaling and ventilation systems. These issues led to multiple delays and millions in added cost. COVID-19 too also played a major role in the budget surge. Labor shortages, supply chain disruptions, and pandemic-related safety requirements added time and complexity. Construction in dense urban corridors too, including new elevated tracks and station builds, encountered additional obstacles like soil instability and community resistance, forcing design changes mid-construction. Furthermore, the cost estimations at the outset were considered optimistic. Experts noted that the initial figures didn't adequately account for inflation, evolving scope, and environmental remediation. By the time the first REM segment opened in July of 2023, from Brossard to downtown Montreal, it was already clear the rest of the system would take longer and cost more than expected. While the REM's fully automated trains, frequent service, and all-electric operation are expected to improve the regional mobility and reduce car dependence, the project's budget overruns have led to criticism from watchdog groups and taxpayers. In the broader context of Canadian infrastructure, the REM is both a bold modernization effort and a cautionary tale. It shows how even well-financed and technologically forward-thinking projects can suffer from underestimating complexity, legacy system integration, and urban construction hurdles. While the REM may still deliver long-term benefits in its reduced emissions and better transit access, its substantial cost overruns show the persistent challenge of forecasting and controlling budgets in large-scale urban engineering.